Okay, students, next is question number 4 I will do, okay? So what it says, find the intervals. This time we have to find intervals in which the function f given by this. Okay, this is a function, so it will have graph, right? So whatever graph it is, they are asking you find intervals. You have to find in x-axis between what interval your graph is increasing, b decreasing. So this function obviously will have graph. You know how to draw graph, right? So when you draw graph of this one, it will come out something in the graph paper, right? Something will be come out. So they are asking under which interval your graph. Suppose the graph is like this, then we will say that between this interval the graph is increasing, and suppose the graph is like this between this interval, then we will say between this interval we will the graph will be decreasing. So we have to find these intervals, okay, between what means x values, this one, okay, x values we have to find under what interval this graph will be increasing, and between what interval it will be decreasing. Okay, so very simple. Here I told you that with the help of derivative we can find out, right? If the derivative, that is slope of tangent, it is positive here, that is slanting here, that is derivative, if it is positive, then the graph will be increasing. Okay, and if it is 0 means it is parallel there, and then decreasing means the slope of tangent will be like this, right? Means angle will be more than 90 degree, that is derivative you will get negative for this kind of points. Means here in this interval you will see that the derivative of the function will be negative. Okay, here between this interval, wherever you find out, here or here or here or here, x, whatever, wherever you find out, your slope of tangent will always be positive, means derivative always positive. So basically what we have to do is, they have given fx is equal to 2x square minus 3x. This function is given, so obviously it will have graph. Okay, try to understand like this always. Now this graph obviously it will be increasing or maybe decreasing somewhere, right? So where it is increasing and where it is decreasing you have to find out. Means in x-axis you have to find out where the graph will increase, between which interval, and between which interval it will be decreasing, right? So how to find out? Very simple. We will find out derivative of this one. It will be 4x minus 3, right? Now we know that if this is positive, that is if this is greater than 0, then it will be increasing, and if it is less than 0 it is decreasing, right? And if it is equal to 0 it will be neutral there, right? So where it is increasing, can we find out from here? X value, for x, for what value of x I will take here, which value I can take from here? X axis 0 if I take, what it will be? 4 into 0, 0. 0 minus 3 is minus, negative. Can you see when I took 0, x 0, then your derivative of this function becomes negative. Means what? The graph of this one will be decreasing at 0. Means it comes like this, or it might be here also. Okay, means it will be decreasing. The graph will go down like this. Okay, if I take 1, what it will be? 4 into 1, 4 minus 3, how much? 1, right? Positive value. Means when I take x1 here, the graph of this function will be like this, upward, increasing. Okay, now in this way, in which interval it will be increasing and which interval it will be decreasing. So for that, what I have to find? We have to find what value, for what value of x this is positive. That's what we have to find out, right? If I can find out for what value of x this is positive, means greater than 0, those value we will say that, means there in under those interval we will say that the graph of this function will be increasing. Okay, so we have to find out those values here. So how to find out? Very simple. Solve this inequality we have done in class 11 only, right? 4x minus 3 greater than 0 it should be, right? So for what value of x this will be, this function, this whole thing will be greater than 0. Solve this inequality we have done in class 11, this one. 4x minus 3, let's bring this side, it will be 3, which implies x will be how much? 4. Can I bring this side? Yes, 3 by 4. The inequality will not change here, right? You know that if I put minus both sides, then inequality used to change. Remember this condition we have studied in lower class, right? That is in class 11 we have studied. So x greater than 3 by 4 we got, right? After solving this inequality, means what? It means this will be greater than 0 in equation also. x plus 1 equal to 0. We used to solve, right? This equation used to bring this one this side and used to solve. Now what is the meaning of this one? This means what? Minus 1 is the value of x. Okay, minus 1 is the value of x, which if I take and put it here, it will become 0. Okay, so here also I have to find out for what value of x this is greater than 0. So what we will do, we will solve this equation, inequality. So x we got 3 by 4. So we understand that x greater than 3 by 4, whatever you take here, it will be always greater than 0. For example, let's take, if I take 3 by 4, suppose it's not equal, right? I will take suppose equal to 3 by 4. What you will get? 4 into 3 by 4 minus 3, which is how much? Equal to 0. Can you see? You won't get greater than 0 here when I took equal to. But if I take greater than this means what value I will take? 3 by 4 means what? 0 point something, right? Let's take 1 then. X greater than this means what? I can take whatever value greater than this I can take, right? So let's take 1. So if I take in place of x 1, you will see that this value after solving it will be greater than 0. X into 4 into 1 minus 3, how much? It will be 1, which is greater than 0, right? You take 2 in place of x. 4 into 2, 8. 8 minus 3, 5. Greater than 0, right? So you take any value greater than this, it will be always greater than 0. Means this will be positive. Means your derivative will be positive. For what? For all x greater than 3 by 4. 3 by 4 also you cannot take. If you take 3 by 4, then it will be equal to 0. If it is equal to 0, then also your derivative won't be increasing. Increasing it will be only if it is greater than 0. Your derivative is greater than 0, then only it will be increasing. Okay. So how to write down this answer? So very simple. First thing you write down given. Okay. Fx, the function which is given, you write down that 2x square minus 3x. Okay. Now differentiate directly. Differentiating with respect to x, what you will get? F dash x is equal to 4x minus 3. Why we are differentiating? Because we have to find out under which interval this graph of this one will be increasing. So that we can find out with the help of slope only, derivative only. If derivative we know it is greater than 0, then this will be increasing. If it is less than 0, it is decreasing. So we know, you can write this one as 1. If f dash x greater than 0, then fx or f is increasing. Better write down f. F is increasing. Okay. If f dash x less than 0, then f is decreasing. Okay. F is decreasing means the graph of this one will decrease like this. Now f dash x greater than 0 imply 4x minus 3. F dash x is what? This one, right? 4x minus 3 greater than 0, which implies x greater than 3 by 4. Right? So whenever your x is greater than 3 by 4, this will be greater than 0. Okay? That is, what can I write? For all x belongs to see I will write down the interval now. If x is greater than this, how I can write? Open interval 3 by 4 to infinity. Means for all x belongs to here, from here greater than 3 by 4, whatever you take, right, greater than this, it will be positive. Means what can I write? X belongs to this interval. X belongs to this means what? 3 by 4 I am not taking. Greater than 3 by 4, whatever is there, that x I will take. Okay, till infinity. When I take for all x belongs to this, f dash x is greater than 0. Can I say? I hope you have understood. For x greater than 3 by 4 means what? X belongs to this only, right? 3 by 4 I am not taking. See here, because for 3 by 4 it is not greater than 0. This won't be greater than. It is greater than this. If you take greater than this, whatever value you will take till infinity, then it will be greater than 0. So I can write this way, right? So that's why under this interval your function, the graph of this, not this one, the graph of not this one, this is just a test. Okay, so for all x belongs to this, means x, if you take anything from here, your graph will be always increasing. Okay, it will go up. So we can write, so for all x belongs to 3/4 comma infinity, fx is increasing. Now student, what they used to make mistake here is they used to write f dash x is increasing, not f dash x. Our test is on this function, whether this is increasing or decreasing. This f dash x we used to do just to test. Okay, find out where the interval will increase, where the interval will not increase, and I have explained how it works. Okay, with the help of slope we can say the graph will be increasing or decreasing. So when your slope is greater than 0, your graph is increasing, fx is increasing. Okay, so for x belongs to this interval, so under this interval your x is increasing. So if I try to explain this one in the graph, so from 3/4, greater than 3/4 means greater than 0 point something it will be, right? So from there the graph will increasing. Okay, like this, it will keep on moving upward only, it will never come down. Okay, that's what we understand the graph of this. Next, so this is a, right? This you can write here, a you can write here. Okay, from here we are testing, right? It's for increasing. Next, for b, decreasing you have to find. So obviously decreasing, where it will decrease? Less than this one. At 3/4 it will be 0. Remember, exactly 3/4 if you take, there it will be 0, means the graph will change from there. Okay, it is increasing here, right? So from here it will decrease, it might come like this from there. Okay, so at 3/4 it is 0, so there the tangent, if you find out, it will be 0. So less than this if you take, it will be always, you can check from here only. In place of, where it is equation, this one, in place of this one 3/4 if I put, what you will get? 0, f dash x 0 you will get. So there it will be neutral. So we have to find b is what? B question is you have to find interval where the graph is decreasing. So where it will decrease? Just less than this if you take, 3/4 less than this if you take it, whatever value you take. Say 0 is less than this, right? Yes or no? It will be 3/4 means what? 0 point something. So less than this will be what? 0. If I put 0 here, what you will get? If I put 0 here, 4 into 0 is 0, minus 3 is minus 3. So it will be negative. Can you see? So if I take even 0, so at 0 also it is decreasing. So just less than this, whatever value is there, all those if you take, after that whatever value comes out on your left, whatever value till minus infinity, whatever you will take, you will see always f dash x will be negative. Negative means those under those interval we will say that less than this, all here the graph will be decreasing, 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 decreasing like this. Okay, so it might come like this also, graph might come like this also. Okay, so if you take less than this, always the graph will be decreasing. You can see graph always we used to take from left to right. Okay, left to right. So here it will be neutral, then it will change its direction, it will be increasing like this. Okay, so let's check what kind of graph you will get for this function. So you can see I have already plotted the graph of that. Okay, 2x square, okay, 2x square minus 3x, this was the function, right? So graph of this you can see at 0 also it is decreasing. On from your left the graph is decreasing. Can you see? It is decreasing. So at this, here you will get 3.4 at this point, 3.4. You can see here, somewhere here only it will lie, right? 3.4, somewhere here you can see the graph is changing now. Here it is 0, then it is increasing. Can you see? Everywhere it is increasing. You will never find here x value where it is decreasing. So greater than that 3/4, everywhere graph is increasing. Can you see? So from without drawing graph, I have told you graph will be something like this. It is not focusing. Okay, it will be something like this, the graph, without drawing graph I said. Okay, I didn't took any point here or plot the graph, right? Directly with the help of this concept I have said the graph will be something like this. So it is parabola like this only. Okay, so you can see the application of derivative without drawing graph. We can say what kind of graph you can get. Okay, so with this concept you try question number, okay, 5 you may not be able to do it. Question number 6 you try. Okay, question number 6 is very simple, exactly same kind of function they have given there. Okay, so you try question number 6 yourself. Some questions are there like question number 6c, I will do it for you, and then question number 5 I will do it for you. Okay, so the one which you can do, you try those question yourself. Okay, I believe that you can do now most of the question from this exercise. Okay, so the one which I feel that it's tough, I will do it for you. Okay, and at the end of this I will give you the PDF for this chapter also. Okay, all the questions I will give you, and it is also actually available in the internet also, the questions and all you can find from there also. But most of the question you will see that it used to be, there used to be mistake, and some question they used to give in a tough way. Okay, they used to solve in a very tough manner. So it's up to you whether you want to follow that or not. But if you got the concept, I believe that you can understand from the internet also. If you download the notes, you can understand from there also. If you find it tough, you can do it yourself, because most of the question I'm doing here in the class itself, right? So you can see and try to understand how to solve the questions here. Okay, and then you can take help of those notes also. Okay, and by the way, I will give you the notes for this chapter. Okay.